In this session of laws of motion, we are going to discuss about the frictional force between two solid surfaces, and this type of friction force is known as dry friction or solid friction. To understand the concept of dry friction or solid friction, take an object. This object can be treated as the block, and this object or block will be placed on the horizontal surface. The two surfaces are in contact or rough, and the friction force which can arise between these two surfaces will be known as dry friction or solid friction. But this friction force will arise only when you will apply some force on the block such that the block can move or the block can have the tendency of movement or tendency of motion. First of all, consider this case. The block is placed on the surface. You have not applied any force on this block, and hence this block does not have the tendency of relative motion on the horizontal surface, or this block does not have any motion on the surface. Hence, the frictional force will not arise between the two solid surfaces in contact. Now we are going to define the dry friction or solid friction. The dry friction or solid friction exists between two solid surfaces in contact. Force of friction will arise when there is a tendency of motion or possibility of motion of solid surfaces in contact, or there is a relative motion of solid surfaces in contact. Now, consider another case. This block is placed on the surface and you have applied a force on this block, but the motion of the block is not produced, but tendency of motion is produced, or we can say that possibility of motion of this block is produced towards right by the application of this force. Hence, the frictional force at this point of contact will arise and the friction force will act towards left, because the direction of friction force will be such that it will oppose the tendency of relative motion. Now take another case. This is the block on which we have applied a larger amount of force. Due to this larger amount of force, the block will have the motion on the surface, and hence the block will have the relative motion on the horizontal surface or the table. That's why the frictional force will arise at this point, and the direction of friction force will be such that it will oppose the direction of the motion or the direction of relative motion. As the block has the motion towards right, hence the frictional force on the block by the horizontal surface or by the table will be towards left. Now we are going to discuss about the frictional force acting on this block. The block is at rest on the horizontal surface and we have not applied any forces on the block. Hence, the block is rest on the table or on the surface. Normally, it is a misconception that if the surfaces in contact are rough, then the frictional force will arise. But the condition is that the surfaces must be rough, as well as you have to apply some force on the block parallel to the table such that the block will have the tendency of relative motion or the possibility of motion, or we can say that the block will have some motion on the surface. But we have not applied any horizontal force on this block, and hence the block does not have any possibility of motion on the table, or the block does not have any motion on this table. That's why the frictional force acting on this block will be 0. Now we are going to draw the free body diagram of this block. The different forces which will act on this block will be given by, the first one is the normal reaction, which is acted by the table, which will act vertical upward by the table. Now the next force will be the weight mg, which will be applied by the earth and it will act vertical downward, but the frictional force will not act on this block and the value of frictional force will be 0. Now take this another case. Now we are going to calculate the frictional force acting on the block by the table. We have applied a force F, and by the application of this force we have produced the possibility of the motion of the block towards right. Hence the frictional force will arise at this point. Now we are going to draw the free body diagram of this block. The forces which are acting on this block will be the applied force F by the external agent towards right. Now the next force will be the gravitational force which will act vertical downward. The next force which will be the normal reaction by the table, and the fourth force will be the frictional force acted by the table, and this friction force will act towards left because the block will have the tendency of relative motion towards right due to the application of this force F. We have applied a force F, but the block is not moving. Hence the acceleration of this block will be 0. Now we are going to apply the Newton's second law along the horizontal direction. According to the Newton's second law, net force equal to mass into acceleration. Hence this F minus this F will be the net horizontal force. This will be equal to mass into acceleration, as the acceleration of the block is 0. Hence F minus F will be equal to 0. Hence the frictional force will be equal to applied force F. This friction force is known as static frictional force. This friction force is known as static frictional force because we have applied the force F, but the motion is not produced, but the tendency of motion is produced and the block is at rest. That's why this frictional force is known as static frictional force, and this static frictional force will be equal to the applied force capital F. Now we are going to increase this applied force capital F. As you increase the applied force capital F, the frictional force will increase, and hence this maximum applied force up to which the block will be at rest on the table is known as limiting static frictional force, right? Now what is the use of limiting static friction force? Let us assume that the limiting static friction force between the table and the surface equals to 50 Newton, and hence we can say that at least we have to apply the 50 Newton force, then after that the motion of the block will start on the table. Hence by knowing the limiting static frictional force, we can apply a force after which the block will start the motion on the table. That's the use of the limiting static friction force, right? Now we have applied a force F on the block such that the block will have the relative motion on the horizontal surface. That means the block starts moving on the surface or on the table like this. Due to the motion of the block towards right, a friction force will arise at the point of contact, and the direction of friction force will be towards left. This type of friction force is known as kinetic friction force. This kinetic friction force will arise on the block when the block will have the motion on the surface, right? Now we are going to draw the free body diagram of this block, and the forces which are acting on the body, which given by one is the applied force, next one is the weight mg which will act by the earth, that will act vertical downward. Next force will be the basically frictional force, and this friction force is the kinetic friction which is denoted by Fk, and it will act towards left because the motion of the block is towards right. And the next force will be the normal reaction acted by the table on the block. Now we are going to apply the Newton's second law on this block. Obviously the block is in motion, hence the block will have some acceleration A. External force on the block along the horizontal direction is given by F minus Fk. This net external force will be equal to mass into acceleration of the block. Hence using this equation we can find the acceleration of the block, right? Once again we are going to revise the main concept of this session. The first concept is very important. Whenever the surfaces are in contact will be rough, then the frictional force at the point of contact will arise. It's not true. The frictional force at the point of contact between two rough surfaces will arise when there will be some tendency of relative motion or there will be some relative motion. Now the second point is that the direction of frictional force will be such that it will oppose the tendency of relative motion or the motion. Third point is that there are two types of frictional force. One is the static frictional force, another one is the kinetic frictional force. The maximum value of static friction force is known as limiting static frictional force, right?